Hi there, Scott Moyes here from Cadbury Systems in New Zealand. I've had a question asking me about how to program a part that's been turned in a manual lathe. So the part on screen there here now, the bore has been removed and then profiled and grooved using a manual lathe. And then the remainder of the part then needs to be milled out using a 3-axis milling machine. So I'll show you how to define the stock and then do the first operation or the first setup and then flip it over and do the next part. Okay, so first of all I'm just going to show you how I went about modeling the stock. So essentially this part was turned out of a round piece of stock, cylindrical stock, so I replicated that by creating a sketch and modeled it off the center point of the bore and then extended it out as far as I needed to go to get some clearance off the largest radial tab in the model. That was all fine, and I had a kind of a hole through the middle of it, but as you can see here I still had a bit more material to remove. So I offset some surfaces, and if I just hide this body here a second, you'll see that I've offset all of the internal surfaces that are relevant, so I can then patch up the result using two surface fill surfaces. Then I've knitted those together into a solid, which has then allowed me to do a combine subtract to end up with a piece of stock that looks like this. Okay, so at this point I was able to then set up my first job. Make sure you select the model. Okay, you can select it from on screen or you can select it from this transparent browser. The stock I'm going to select from solid, and then from the browser I'm going to select my combined body. I don't need to continue machining from the previous job because this is the first one, and I'm going to stick with stock and orientation, but I'm going to change my front plane. Well, you know what? Looking at this, I need to make sure that I'm machining it from this side first. Okay, so my Z-axis is pointing in the wrong direction, so if I clear this selection and then just select this top face, now the Z-axis is pointing the opposite way around, and I'm happy with top center. So putting this on my mill, I've got a bit of an excess stock on the top, the bottom face has been faced off on the lathe, so yeah, I'm good with that, and I can create my G54, my work offset, and my control at the center of this cylinder. So that's perfect. Now I'm all good with that. I don't need to set anything else. So I've got my stock defined. So the first operation I'm going to do then is just a simple facing operation. I'm going to come into my tool library and select 50mm face. Now these have all been saved into my document here, but you can pick them out of the library that's been shipped with HSMWorks, or you can create custom libraries, etc. Right, so I'm using my 50mm face mill. I don't need to select anything else, and that's it. I've just faced off the top of the part. Now I need to start looking at how to remove some of this material. So I've just faced down to this edge here. So let's use 3D adaptive clearing. I'm going to change my tool. I'm going to use a 16mm flat end mill. I don't need to select anything in the geometry tab here, but down at rest machining I want to make sure I change to from previous operations, because I want the toolpath to take account of the fact that some of the material has been removed in the previous operation by the face mill. And I'm happy with all of those settings there. I don't need to do anything else, but I do want to make sure that I go 1 mil past the model bottom. Now in the real world I'd probably leave a bigger flange on the bottom of that because I want to hold on to it in the vise, but at the end of this series of videos I want to have a simulation that's just going to have a completely finished part. Okay, so here I'm coming straight past the bottom of the part by 1 mil. Then in the passes tab I'm going to change over to a larger step down because I've got a 16mm tool, so I should easily be able to go 2 times the diameter in the depth. So it's a 16mm tool, so I'm going to go with 32mm, and I'm going to turn on flat area detection. Now what this does is it looks down through the model and it finds all of the different horizontal planes at the different heights, and if they fall in between the 3.2mm fine step down, then it's going to adjust the step down slightly so that it can generate a toolpath that's within 0.5 of a millimeter axially from that face. It's going to leave 0.5 of a mil of stock on the horizontal faces, and I'm going to leave all the linking and leads as default. So while that's generating, I can move on to do the next one. So I'm going to use horizontal. I'm going to keep using the same tool, and from the model top I'm actually going to change the top height to model top -1 mil, because I've already surfaced the top face here and I don't want this horizontal strategy to drop any toolpaths on it, because what it does is similar to flat area detection, is it looks down through the model and finds all of the horizontal faces and applies toolpaths to them without having to select them all individually. I do want to leave some radial stock to stay away from these walls, because I'm going to come back and do a finish pass to clean those up, but I want it to be a finish pass on the horizontal faces, so I'm going to set that to 0 on the axial stock to leave, and I'm going to leave all the linking and leads as default. If we do a quick simulation on this stock simulation, we'll see how far along we've got. We've got pretty far along the way of removing most of the stock from this side. Now we just need to start doing some finishing passes on the walls of the model and apply the, if we turn this transparency on here, come up with a toolpath to surface this fillet on the top of the job. Join me in the next video to apply some 2D contours to finish off some of the vertical walls on this part, using both model geometry and also making use of the Create Silhouette tool. And then finally we're going to go around and apply the flow toolpath to this particular fillet here to create a finished surface. Thanks for tuning in, have a good day, and we'll see you next time.